In this example, we're going to explore what happens when we multiply the inside of a function by a constant. So I'm here in Desmos. I've got the graph of the function p of x plotted, and then I've also graphed the function w of x, where w of x equals b times b of b times x. So b is a constant. It's multiplied on the inside of the function, affecting the inputs. So let's see what happens as we let that number b get greater and greater and greater than 1. So as b gets large, oh, look at that. The graph gets narrower. So it turns out that when we multiply by a number bigger than 1 on the inside of the function, it affects the inputs, it affects the horizontal behavior of the graph, which should be expected because it's literally being multiplied on the inside, affecting those inputs. But the thing that's kind of opposite of what we might have expected is that as that number gets big, the graph gets narrower, the graph gets compressed horizontally. So for example, if we let that number be 2, x values that used to be here at -2 are now half as big at -1. X value that used to be over here at +3 is now at about 1.5. It's being compressed horizontally by a factor of the reciprocal of this number. It's 1/2 as big horizontally because of that number 2. Now let's see what happens when we let that number get small. As that number gets closer and closer and closer and closer and closer to 0, it turns out that the graph gets stretched horizontally. So if we make that number 0.5 or 1/2, it turns out the graph gets doubled in the horizontal direction. You can see a point that used to be at -2 is now doubled at -4. So the behavior is the effect of that number less than 1 is that it stretches the graph by a factor of the reciprocal of that number. Instead of being half as big, it's twice as big.